Okay, we're going to talk about part 3b, Relational Database Management System, or RDBMS for short. This is the last part of your introduction to database. After this video, you can continue working on your uh, C4, alright? After this, we will move on to the actual coding part, right? Okay, so what is a RDBMS? Right, so this is a database management system software. So DBMS is a software which enables the definition, creation, and querying of a large collection of data. Right, so basically what you do is that you put in your database, all the tables and all the data into your DBMS, right? So this software helps you to do a few things. It helps you to back up your data. It helps to provide some security for your data. It also let you, through the use of SQL queries, right, get some information about your data set, right? It also can control access, so not all users can access all parts of the database. And all these things are done by a database administrator, which can be a single person or team of people, right? So let's go on. Okay, so first thing first, we're going to talk about concurrent access to data. Okay, so one of the key features is that there is control over multi-user access to data, right? So I can lock, so I can prevent multiple users from. Okay, I allow multiple users to access the database, but I don't allow them to work on the same record at the same time, right? Okay. So for this, so I could possibly lock the entire database, so to prevent activity from all other users. So this lock on the entire database could be useful when the company is doing a whole database upgrade or something like that. Like for example, recently your cosmology was locked for about 6 hours. So it's probably because they had to update the entire database. So if you try to access the database if they let you access the database at that point of time, right, you might end up creating new data that will not be transferred over to the new database. Okay, next. So this is what we call total locking, right? So just how we just said that, right? So this total locking. All right. Then there's also table level locking. Okay, so I could lock certain users from accessing certain tables, but they can use other tables at the same time, right? But this is a bit tricky because sometimes when you want to make a transaction, right, your transaction could involve taking information from multiple tables or updating multiple tables. So this one there might be some issues, right? Okay, next I could also log individual records. So for example, let's say if I'm talking about my student database, and one of the students withdraw from school, right, I may not want to delete the record outright. I may just want to set the person's status as withdrawn and then just lock the record so no one else can touch it anymore. All right. So yeah, so this is why it is important for you to be able to lock one record, because if you don't lock one record, right, when one user is accessing it, right, another user may try to access it at the same time. Okay, so this will cause your updates to be lost, right? Okay, now we talk about data security. Okay, in this case here, security is talking about keeping your data safe in the sense that you don't lose your data. So the easiest way to do this is through doing backup. Okay, so in the case of a DBMS, right, the DBA can do the backup on its own. All right, so let me just show everything first. All right, so because all the data is held within the DBMS, right, it's easier for you to plan to do the backup. All right, so you can do a backup by saving it onto a file on the hard disk and other storage medium. Okay, and then also because you don't want your database to lose records. So what you can during a power outbreak, right? So what you can do is that you can also create a backup on a very regular basis, right? So backup could be a few types. It could be on-site. So on-site means I'm storing it within the same server or maybe another hard drive, okay, or on another server within the same physical premise, or off-site. That means I put it at another server located at a separate location. So off-site backup will take a longer time because it has to be transferred over the internet. However, off-site backup is also one of the preferred options. Because offsite means that if let's say your current site is affected by some electrical electrical failure, or let's say like some maybe fire or other natural disasters, right? Then you might lose the data, even though you have a backup on site. So usually DBAs will do both, because on site is fastest. They can do it maybe like even every few hours, depending on how critical your data is, right? They may want to do a backup every few hours. Okay, that's on site. Then maybe every 24 hours, right? They will do an off-site backup. Okay. So why is it important to do all these things, right? To do your backup and so your database maintenance, right? Okay, so it's to improve your database performance by performing garbage collection. Okay, so garbage collection is when you delete away your, let's say you delete away a record, your record is not actually deleted, it's actually marked as deleted. Okay, so when you do garbage collection, right, you're just going in to actually delete those records. So that will free up space. Okay, next you also can let you make updates to the database page size, or distributing the database among multiple files or this. Okay, so this one is not really in your syllabus, right? But typically, if you some of you might have heard of RAID configuration. This is basically creating hard drives to work in groups. So there are some configurations where basically one piece of data is split into two equal portions and placed on two hard drives at the same time. So this is fastest, right? So, or if you want to do it in a very secure and safe way, maybe every piece of data that goes in, right, will be safe. Will each a copy will be safe on another hard drive, right at the same time. Okay, so this will give you a backup. Okay, then also your DBA does not need to shut down your server does not need to shut down the database to run the backup, right? And basically create a snapshot lah, right? Yep, so you can read the rest of this page on your own. Okay, next, just a quick summary on what we have learned so far. So, relation database is a collection of data records with predefined relationships between them. So, we can use ER diagrams to represent this relationship. Okay, so records are organized as a set of tables with columns and rows. Okay, remember, rows are records, columns are your attributes, right? Then each record has a unique identifier called primary key. And then yeah, we can link rows between multiple tables using foreign keys as well. Okay, so this is an example of your ER diagram at the bottom here. Right, let's go on. Okay, so we're going to start a little bit about SQL concepts. So I won't be talking about the actual writing of SQL statements here, but I'll just give you some background to it first before the next topic. Okay, so SQL stands for Structured Query Language. It's used to perform CRUD operations, CRUD, on the database. Okay, so what exactly is CRUD? CRUD stands for Create, Read, Update, and Delete. Okay, so most of your database actions, right, will fall into one of these four types. Okay, so you're either creating a new table, creating a new database, you're reading something, you're reading a record from one of the tables, you are updating a record from another table, you are deleting away a record. Okay. Alright, so there are constraints being set. Okay, so constraints basically help to enforce data integrity. Okay, what we do is that, for example, let's say you ask the user to create a new record that contains the IC number. We know the IC number has a structure that is a letter in front, then 7 digits, then followed by a letter at the back. Okay, so we could force a user to enter it in this way. If not, we can reject it. Okay, so this one sounds a bit too extreme. It sounds a bit too for the lack of a better word, niao, right? But yeah, it helps you to maintain the overall completeness, accuracy, and consistency of your data, right? Okay, so these are some of the possible things that we want to use as constraints. For example, we don't want certain entries to be empty. So for example, let's say you're running a shopping website. You want the address of the user to be there. If not, you have issues when later if the user buy something and you can't deliver it. Right? So transaction in relation database. Okay, so a transaction, right, is one or more SQL statements that are executed as a sequence of operations that form a single logical unit of work. Okay, this sounds very complex, but basically, right, your SQL statement here, there are various parts as update item, set price, etc., right? So all these parts here form a single transaction, Alright, so this line will not work if let's say one part of it is not wrong. One part of it is wrong. So for example, let's say you can't find a name of the product called mini fridge, right? Then you will not be able to update the item price to 450. Right? Okay, so this is all or nothing. So every part of the SQL statement must work for the entire transaction to go through. Okay, so when another term that we're gonna learn today is called commit. Okay, so once you have a successful transaction, right? You also need to commit it. So this is like basically saving the change is similar, but for database is important. When you make updates, right, you need to do a commit. Okay, if you want to roll back, right, that means you want to take back whatever you have done, right, you also can do a rollback as well. All right. Okay, so we're going to talk a little bit more about transaction, the requirements for a transaction. A transaction, right, need to be ACID compliant, ACID compliant, okay, to ensure data integrity. So we're going to talk about what A, C, I, and D are. Okay, first one is atomicity. Okay, so atomicity requires that either transaction as a whole be successfully executed, or if part of it fail, right, then the entire transaction be invalidated. So let's say you are at a shopping website. Let's say like you are on Shopee. The way for you to buy things on Shopee is to add the item into the cart, okay, into your personal cart. Then you add your payment details, then you confirm payment, right? So all these things need to take place. But if let's say you don't add item into cart, right? So right now your cart is actually empty, so you will not be able to make add payment details, and you can't confirm your payment. So the whole transaction will fail because your card is empty, right? So this is atomicity. So it's in this case it's like either everything must be correct and work, or if one of it is off, right, then the whole thing will the whole transaction will fail. Okay, so there's atomicity. Okay, next we have consistency. Consistency mandates the data to be written. So this was what we talked about the constraints just now. Okay, you must follow all your defined rules and also the restrictions, including constraints. Okay, so let's look at an example now. Let's say you are asked to add your card details. You're asked to enter the name on the card. So let's say John Tan. Then you are asked to enter your 16-digit card number without spaces. Then you go and enter with spaces, 4313 space 2134 space, so on and so forth. You enter the rest of things correctly, right? So this will not work because you are not following the constraints of your database. Okay, so in this case your transaction will be rejected. Okay, that's consistency. Yeah. So every transaction needs to be consistent. It must follow the rules of the database. All right. Next, you have isolation. Okay, so this is to make sure each transaction is independent onto itself lah. Okay, so I'll give you an example. Like recently, there was a BTS meal, right, at McDonald's, right? So let's say, okay, you want to buy the meals, and there are 6 meals left. Okay, and user A tries to buy 4 BTS meals, and user B tries to buy 3 BTS meals at the same time. So if at the same time, right, there will be an issue. Because if let's say you let both transactions go through, right, you're gonna have you will end up having to sell 7 meals which you don't have. Okay, so in this case, right, the server will probably need to do something to decide whether to which transaction to accept. I think in terms of fairness, usually they use by timing. See which transaction goes in first. So for example, let's say like maybe buyer B wants the one that goes in first. He buys 3 meals, so 3 meals are gone, and then buyer A tries to buy 4 meals, right? He won't be able to buy so because at that stage there's only 3 meals left. Okay, so this is talking about isolation. Okay, last thing, durability requires that all the changes made to the database be permanent once the transaction is successfully completed. Okay, so this is talking about the commitment part. Okay, you need to commit your change. Alright, so what's happening here is that, for example, you go back to the first example, you add item into cart, you add payment details, you confirm payment. Okay, once you confirm payment, right, 2 things will be done. Okay, you will receive a confirmation email about your purchase. Okay, and then the database, the DBMS also write into the database and commit that change. Okay, so let's say you bought like you bought 3 BTS meals. That means now you're gonna have in your stockpile, right? You will have 3 less meals to sell. Okay, but what if your writing into database is not done, right? The transaction is not recorded. Okay, so even though you might have received a confirmation email, but later when you click in to see, right, it might not work because the transaction was actually not recorded by the DBMS. Okay, so this is something that has to be done as well, lah. All right. Okay, so we'll end part 3B. Please complete your C4 database ER diagram. Okay, after this, I think we will start with C5 where you talk about SQL. Thank you.